Hey y'all, it's me, Miss B. Today we are learning the parts of a quadratic function and how to make vertical transformations. Now we've already learned about transformations previously, but this is focusing on parabolas only. So remember that a parabola has the equation f of x equals x squared. Remember that y and f of x are the same type of thing. F of x just means that it's actually a function of x, so it's more specific. So here I'm going to fill out a table. These numbers over here, people always ask where I got those numbers. They're just random numbers. You can pick any numbers you want, but these numbers, I chose them because they're small, they're easy to plug in, and I can get a general idea of the shape of it without having to go off of this axis that I have here. So when I square -2, plug in that -2, I get, and you have to put parentheses around it, and your calculator as well, I get +4 because two negatives, so -2 squared means -2 times -2, which is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So then I'm going to graph these points. So I have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So then I'm going to draw, and it's supposed to look like a curve. Those shouldn't be straight lines. Looks like that. Okay, so this is the function f of x, this is the table for f of x, and this is the graph of f of x. All right, so you're gonna have to pause and maybe write down some vocabulary. I'm gonna run through it. So first we have a parabola, which is the shape of a quadratic function. That's gonna be our U shapes, so like this or like this. A quadratic function is y equals x squared or f of x equals x squared. We're mostly going to see f of x. Vertex form is y equals a times the quantity x minus h squared plus k. I'm going to highlight this h and k here. Because they come up down here. And that hk is a low or high point on the graph. And it's the vertex of the parabola. Your axis of symmetry is going to be the equation of line that cuts a parabola in half, and this is an extra note. It's going to go through the vertex. And then the vertex of a parabola is on the axis of symmetry. A minimum value is a value of the lowest point, and a maximum value is a value of the highest point. So I'm going to take this graph over here and label some things. So this right here, this low point right here, that is what we call our vertex, and we label it HK. And then our axis of symmetry is this line. It's usually represented as a dotted line. And we call that the axis of symmetry. And its equation is always x equals h. Notice that we have x equals h and hk as our point. Okay, so we're going to talk about vertex form. This B here doesn't get used a whole lot, so I'm actually going to erase it, and I'm going to block this stuff out because it's not really needed. Okay, so you can go ahead and cross those two off on your graph. You also need to change this to h and k. So looking at vertex form, a times the quantity x minus h squared plus k. A is a vertical stretch or compression by A, and then it's going to reflect over the x-axis if it's negative, and then h shifts it left or right, and k shifts it up or down. And we remember seeing this because we saw it with, we had an equation that was like a x minus c plus d. And so the only difference is, I forgot my f of x. So we had a f of x. The only difference is that our function f of x is equal to x squared, and our CD is now an HK. You don't have to write that down. Okay, so let's do some examples here and just talk through what each of these does to the graph. So I have a value of 1/2. So A is equal to 1/2. That causes a vertical compression by 1/2. Okay. If I were to rewrite this as 1/2 f of x equals 1/2 times, and then I only have x squared, and so I have a 0 and a 0. That means that my vertex HK is equal to 0, 0, and my axis of symmetry which is x equals h is x equals 0. And then if I'm deciding between have a max and a min, if I have, we'll graph it first and then I'll tell you. Okay, so let's go ahead. I'm going to darken these lines for x and y axis. You know what? I'm even going to move this down a little bit since. Okay, so this is my x-axis, this is my y-axis. Okay, so all of my points before were, this is my parent function. And I'm getting this just from our table that we did on the very first page. So this right here, this is the parent function. So I'm just going to write these values down. So I have -2, -1, 0. Actually, you know what? Let me do something else. We're only going to do zero, 1, and 2. Okay, so we had 0, 0, 1, 1, 2, 4. And these are going to become, change my color again. So this value, 1/2, is changing y. So I need to multiply all my y values by 1/2. So my x's stay the same, and my y's are getting multiplied by 1/2. So I have 0, 1/2, and 1. Oh wait, 0, 1/2, and then 4 times 1/2 is 2. So then I'm going to graph those points. So I have 0, 0, 1, 1/2, and 2, 2. Now I'm going to show you something over here. Notice our vertex is at 0, 0. This is 0, 0. then we also have axis of symmetry at x equals 0. So that's the vertical line. Vertical line on the y-axis. So what that axis of symmetry does is each of these points gets reflected over here. So this is a reflection point, and then this point gets reflected. So this is 1, 2 away, and we go 1, 2 away. So then I can just graph this. So using the axis of symmetry saves us from having to graph all of those points. Okay. Let's do another one. Let's do this one down here, negative 2x squared. So this negative here is going to cause a reflection over the x-axis, and this 2 is going to stretch it by 2, like Laffy Taffy. Okay, so I'm going to rewrite the equation as f of x equals negative 2 times x minus 0 squared plus 0. So my vertex is at 0, 0. And my axis of symmetry is at x equals 0. Take this. Oop. Okay. So here's my parent function. 0, 1, 2, 0, 1, 4. So then now I need to multiply all of my y values by negative 2. Actually, I'm going to already put the vertex at 0, 0, and then draw my axis of symmetry. X values stay the same, y values by negative 2, so 0, negative 2, negative 8. I actually need to move this up just 1, so we're not going to have enough room otherwise. Okay. And the axis of symmetry is under that line. Okay, there we go, we fixed it. So plot the point 0, 0, have that 1, negative 2, and 2, negative 8. Then we'll reflect these points over, so this is 2 away, so this is now 2 away, and then this gets reflected as well. We draw our lines, make sure to make it curved, and so that's our new function. Okay, so you can see it got stretched like Laffy Taffy, and it got flipped over upside down. So let's talk about our max and our min. So for this one, I obviously have a minimum because I have a low point right here. So this is going to happen when our a value is positive. Oh wait, that's a minimum. Yeah, I said that. Okay, and then we're going to have a maximum point when our graph is, when a is negative. So that is a pattern that you can notice right away. All right, the rest of the worksheet is your homework.